Thank you for coming to our presentation on the impacts of COVID-19 pandemic-related changes in shipping on the soundscape and calling behavior of right whales in the New York Bight. I'd like to start by acknowledging my co-authors, Julia Zay, Bobby Estabrook, Megan Rickard, and Aaron Rice from Syracuse University, the Cornell Lab of Ornithology, and the Department of Environmental Conservation of New York State. Funding for this project was from the Division of Marine Resources from the New York State Department of Environmental Conservation. The COVID-19 pandemic had significant impacts on global transportation, both from reductions in air travel and vehicle travel around the world to reductions in both commercial and recreational vessel traffic. There have been a number of reports that have documented significant changes in the background noise levels in terrestrial habitats and in some marine habitats resulting from these changes. The image on the left shows a container ship being unloaded in the ports of New Jersey and New York. And on the right is the percent change in the number of containers loaded and unloaded in these ports from 2019 to 2020. What you can see is that the levels of shipping were the same between the years in January and February, and then declined sharply during the first lockdowns of the pandemic from March to June, bottoming out about 16% lower in June 2020, and then rebounding sharply to increase to above the 2019 levels by the late summer and early fall. Right whale acoustic detections peaked at about the same time that there was this reduction in the amount of ship traffic into the ports, so we were curious on what impacts this might have on the soundscapes and on the calls by the right whales themselves. The acoustic recordings used for this study were from 15 sites where data were collected from October 2017 to October 2020, with funding from the New York DEC. The acoustic recorders were located along the major shipping lanes for New York ports, which are shown here with these pink lines. Right whales were detected acoustically across all seasons in these recordings, but there were fewer days of right whale detections on fewer sensors in 2020 than in any previous year. Just to give you orientation to these figures, each of the circles represents one recording unit and the number of days of recordings in a given month. White indicates days that no right whales were detected, and black indicates days that had right whales detected. So for example, these two units had about right whale detections on about half the days. So you can see between April 2019 to 2020, there was a reduction in the number of right whale days detected calling. Looking at these acoustic recorders, we looked at the soundscapes. And so these two plots are power spectral density plots. On the left is from one acoustic recorder in 2019 in April, and on the right is another recording from that same unit in April 2020. We have frequency on the x-axis from 10 to 500 hertz, and then we have noise levels on the y-axis in dBV 1 micropascal per hertz. The color on the image indicates the frequency with which each of these values was detected on the units, with yellows and oranges indicating more common amplitudes, and blues and whites indicating times that were rarely detected in the recordings. This arrow is indicating the 50th percentile or median value of noise in 2019 in the right whale communication frequency range. And this arrow indicates the same value in 2020. What you can see is that these are virtually identical, and there was no significant difference in the median noise levels between the 2 years on any of the recording units. However, when we looked at the 95th and 99th percentile, so the loudest noises on the recorders in a given month, we see that in 2019, there were a number of high amplitude signals that were recorded that were absent in 2020. And the 95th percentile noise levels were significantly lower in 2020 than in 2019. Right whale upcalls were measured. In the top panel, we have a right whale upcall, and we measured the background noise levels, the duration, peak frequency, minimum frequency, and maximum frequency for each of these calls with high SNR, so we had confidence that the background noise level represented the noise that the whale heard. On the bottom, you can see measurements of peak frequency versus the background noise level for 2019 and 2020. And we did the analysis in Raven and in R using Warbler and Tunar for more repeatable measurements. Preliminary measurements show no significant differences in upcall parameters across years, as you can see in this distribution plot. The takeaway points from our study are that the pandemic changes did not result in a true quieting in urban right whale habitats, and the median noise levels were unchanged in right whale communication frequencies in the New York Bight area. Preliminary analysis indicates no significant changes in calling behavior, but there's more work to be done. Thank you.